Good morning. Um, Today I am going to talk about the cost function um, for the students, which is in continuation which what we have done earlier. So let me first start with the proposal, that is a definition of cost, and this is very simple lecture in fact, which is in fact touch upon the very preliminary aspect of cost, and then we will move towards the production aspect. So if that is the case, then it is important to differentiate between accounting cost and economic cost. That is especially the accountant's view of cost, stressed out of pocket expenditure, historical cost, depreciation, and other bookkeeping entries are normally called the accounting cost. So these accounting cost is also very important one, which is called the explicit cost of the firm. So economists focus more on, however, the opportunity cost rather than this explicit cost. Now, what are these opportunity cost? Let us come to the first aspect of it, that is labor cost. Now, before the opportunity cost, which is normally very simply defined as the best, the cost which is actually foregone. Best alternative we forgone. In the case of cost, it is called the cost foregone. All right. So if that is the case, then it's pretty clear that is that what makes us to value something in an X fashion or Y fashion. So that is ultimately depends on this aspect. Now, if that is clear, then we will move towards the labor cost. That labor cost is a cost to accountant expenditure on labor, are current expenses, and hence cost of production. So, for the economist, this accountant's views are not understood, considered. What we do normally is labor is an explicit cost for all of us. That is, labor services are contracted at some hourly basis. Normally, this is what is called the W or wage, and it is assumed that this is also what the labor could earn an alternative employment. So if our W is same in all the alternative thing, then the firms are actually treating the labor as the same. Otherwise, there is a difference which will give the W a different value in X as well as the Y firms. So if that is the case, then things are going to be different. Otherwise, if the homogeneous labor and the need of the consideration or considering firms are same, then your payment is also same. This is what is we all expect. But the real world makes sometimes things different. Not sometimes, often makes it different, and we will come to that later. So that is the part which we have to keep in the labor, which is very simple, the explicit cost. The another sort of an explicit cost normally comes under the economic and considerations capital cost. Now, what is a capital cost for accountant? It is a historical price of the capital and apply some depreciation rule to determine the current cost of the thing. So suppose if you are buying a capital good, say a machine, then what we do normally is that the total price of the commodity and the machine is there, and you will work with 10 years, so you divide that, and then you at the end of the day, still the machine is there, that machine is completely worn out. So what you do is actually you will discount in that sense with that wearing and tearing, and then you see that at the end of the thing, some portion of this will be remaining, that is what is capital, but that will not actually been considered. So over a period of 10 years, if it is the life of this machine is 10 years, so you divide a 10 year with the machine. If the remaining the last after 10 year, if it is remains, then that is we, we won't actually consider because the life is already been exhausted in that sense. So that is how you normally calculate. For economists, referring to the capital original price of a sunk cost and instead regarding the implicit cost of the capital to be what someone else would be willing to pay for its use. So for us, it is actually not as the explicit cost, it's an implicit cost, which is always called as sunk cost. Sunk cost is actually an initial payment which is you have done in a fashion of irrecoverable nature. What that means is very simple, that once you made a payment, it's gone forever. So whether you are doing a production or not, production doesn't matter. For example, suppose if I am buying a machine, if that is actually comes under the category of sunk cost, and what happens is that at the end of the day, at the end of the day, whether you start your production or not, the cost is being borne. So it is irrecoverable. But if you can sell it as it's a different thing, then it is no longer a sunk cost in that sense. So we will use V to denote the rental rate of capital in that sense. Sorry. So cost of entrepreneurial services comes as the third set of cost normally in the economic concern. So accountants believe that the owner of the firm is entitled to all profits, that is revenue or loss left over after paying or input cost is what is called the profit in that sense. But for economists, it is not the case. Economists consider the opportunity cost of time and fund that owners devote to the operation of their firm. So part of the accounting profit would be considered as entrepreneurial cost by economists in that sense. So these are all the three categories in which we normally deal with. So what is actually an economic cost in that sense? The economic cost of any input is the payment required to keep that input in its present employment. So for us, the remuneration the input would receive in its best alternative employment is what is called the cost, which is constitute as a larger portion. So to simplify the assumption for all these categories which we have understood is in the following way. There are only two inputs, suppose homogeneous labor measured in labor hour and homogeneous capital in capital hour, machine hours, or entrepreneurial costs are included in capital costs in that sense. So if you have an input are hired in perfectly competitive market as we decide, theoretically envisaged earlier lectures, firms are price takers in that context. So in the perfect competition scenario, we know that firms are normally the price takers from the market. They cannot actually influence the market in that sense. So economic profit therefore comes as the following. Total cost for the firms are given by total cost, which is C, which is equal to the total WL plus VK, that is the proportion of labor with respect to payment of the labor as well as the capital and its payment. So total revenue for the firm is given by total revenue, which is the total quantity produced times the price which is going to be sold, which is going to be the function of the capital labor, which is basically paid off. So economic profit therefore is a function, that is pi are equal to the difference between these two, that is pi total revenue minus total cost. This is what is in fact the simple understanding, that is the profit. So profit is the difference between the revenue and cost. So economic profit are a function of the amount of capital labor employed. We could examine how a firm would choose K and L to maximize profit. The right demand is actually the theory which we have used normally, theory of labor and capital inputs used here, which is we have already seen in the earlier lectures and all, we have done that. So for now we will assume that the firm has already chosen its output level Q0 and want to minimize its cost. Now, to minimize the cost of production, a given level of output, a firm should choose point on the isochron at which the RTS is equal to the ratio where W by V. It should equate the rate at which K can be traded for L in the productive process to the rate at which they can be traded in the marketplace. Now, if that is the case, mathematically we can express the same as V seeks to minimize total cost given Q is equal to F of KL, which is equal to Q0, setting up the Lagrangian case or Lagrangian multiply. What we get is the following, that is L is equal to WL plus VK plus lambda Q minus FKL. So if you look into the first order condition, then what you go, the partial differentiation of the a Lagrangian case with respect to the change in that is the partial change in the labor, which is nothing but W minus lambda dou F of dou F by dou L, which is equal to 0, and that is follows for all other factors. That is, the same is actually going to follow for the capital as well as the lambda. So if that is the case, then there is no difference is left. So there is no problem as far as the theoretical setting is concerned. So then that is going to give us a kind of an expression which is dividing the first two conditions. We get a W by V, which is equal to the division of dou F by dou L and dou F by dou K, which is equal to the rate of technical substitution or for labor and capital. This is what we have seen. That is how much labor is going to be substituted for how much capital, which is actually a function of the relationship between the wage and the capital's payment. So the cost minimizing firm should equate the RTS for the two inputs to the ratio of their prices in that sense. So if that is the case, then then if we cross multiply, then what we will get is the following, that is F of K by V is equal to F of L or FL by W. For cost to be minimized, the marginal productivity per dollar per spend should be the same for all the inputs in that sense. So that is called we are actually operating in a constant case. We have already seen the same point in the earlier lectures also. That is, our setting is in fact the perfect competition. Therefore, the perfect competition scenario, this is actually goes in a horizontal way because of the perfect competition. The cost of factor or the revenue the factor is going to be constant because nobody can in fact influence or change or bluff or whatever. So if that is the case, then the price which you can get in firm X as well as firm Y is going to be in fact one of the same. That is the intuition. So the Lagrangian multiplier shows how much in extra cost would be incurred by the increasing the output constraint slightly. That is what is you have this particular thing. So given the output Q0, we wish to find the least cost point on the isochron. So if that is the case, then you may be having different cost lines, that is C1, C2, C3, and in that you can have actually a quantity which you can produce. So your convex production quantity production curve, which will actually tangentiate either any of this curve and in this line, and finally you get an optimal case. So costs are represented by parallel lines with a slope of W by V. Then what you get, you have lower and higher cost lines. So if that is the case, then at this tangency where this Q0 tangentiate with any of this cost line, that will be actually perfect thing. So in this case, in this curve, you have a K star L star point where that in the second cost line where you optimize. Why? Because your Q0 tangentiate with the different cost curves in that context. So the optimal choice therefore is L star, K star. So in the earlier chapter, we had already seen, or in the lectures we have already seen, individual expenditure minimization problems as well as the other issue. So we are not going to uh, be detailing all that. So in the present case, cost minimization lead to a demand for capital and labor that is contingent on the level of output being produced. Demand for an input is a derived demand, and therefore it is based on the level of the firm's output. So the firm can determine the cost minimizing combination of K and L for every level of output. So if input costs remain constant for all amount of K and L, the firm may demand we can trace the locus of cost minimizing choice called the expansion path. This is what has been shown in this particular slide. So the expansion path is the locus of cost minimizing tangencies. The curve shows how input increases as output increases. So this is how it is. So the expansion path does not to be a straight line in that as or in the diagram which we have presented. So it can be actually other way around. It can actually go curvy. So the use of some inputs may increase faster than others as output expands. Then it is depends on the shape of the isocon. So if that is the case, then things are going to be not as normal as we think in the E expansion. Bend on any of this direction. The expansion path does not have to be therefore upward sloping. So if the use of an input falls as output expands, so we have also discussed this part in the earlier lectures. Suppose that production function is a Cobb-Douglas case of Q, which is equal to K alpha L beta. So the Lagrangian expression for the cost minimization function, as all of you know, that L is equal to Vk plus WL plus lambda Q minus Q0 minus K alpha and L beta. So if that is the case, as we have said earlier, that your first order condition would be looks like this. And then if you divide the first equation by the second, gives us the same, that is W by V, which is equal to beta K alpha and LB minus 1 B, okay, which divided by the alpha K alpha, minus 1 L beta, which is equal to the beta by alpha times K by L. So this is what was actually we said earlier, this RTS. So the rate of technical substitution depends in this context. So the ratio at which you are ready to change your labor to capital or capital labor. So this production function is therefore is homothetic. Therefore the RTS depends only on the ratio of the two inputs in that sense. That is why this B by beta by alpha is very important in this case. So capital labor ratio therefore is also very important, which is depends on the input ratio which we applies for the production. So the expansion path is a straight line in that context. Otherwise, if it is changes, then the expansion path won't be a straight line in that sense. So suppose that the production function is a constant elasticity of substitution case, that is CES case, then your Q by K rho plus L rho, which is lambda by rho. The Lagrangian expression for the cost minimization production of Q0 is the following. This will give you a case which is also equivalent to say that there is a possibility that a homothetic production case in this case. So you cannot actually have a problem different other than the first case which we have said. So in the CES production, that is the constant elasticity case, you have in the first order condition only your capital and labor has its own thing, but it is not in fact strictly under a strict assumption that it is one. okay, you degree 1. So it can be actually any degree in that sense. That is why you say that you have an R plus KR plus LP, LR, or K row plus L row. So if that is the case, still, you may be having different proposition that is not necessarily sticking to degree 1. You may be having different degrees. Even you can have degree 2, degree 3, or whatever, K minus 1 degrees you can have. So that will give you a kind of shapes of the expansion path leans towards the left or right. So this is what is actually exactly this particular proposition try to make. So if it is degree 1, then of course you have to follow certain rule. That is what is called the Cobb-Douglas case. We have already discussed this aspect, but still I'll come to that in a while. Okay, so in the CES production function also, what we have seen is the uh, homothetic relation, the same. So in the production function lecture, we will discuss the same, little more elaborative. I think I have already done it, but still I'll check with it. Okay, otherwise I'll give you a detailed exposition in another lecture. So a total cost function in that, now if you know this then we will move towards the other aspect of the cost function, like total cost. The total cost function shows that for any set of input cost and for any output level, the minimum cost incurred by the firm is C is equal to C, W, V and Q. So as output Q increase, total cost also will increase. This is why you have to have a Q there. So it is a function of number of quantity. It is also it is also depends on the quantity. It is also depends on the price wage which you pay, as well as the interest you discount in the form of capital payment. And then average, then you will get actually a total cost, which is always an increasing. So when your total output increases, of course your cost also will increase. So whereas if you are looking into the average cost, the mathematically, the relation is the following. That is, whatever you have, the other one, C, V, W, Q, all, which would be divided by the total quantity. So an average cost is nothing but the total cost by the quantity, okay, divided by the quantity. So is found by computing total cost per unit of output. So therefore it is a per unit cost. So when you have a marginal cost in the similar fashion, it is actually the additional cost of any unit of production. So this is why, what is the difference? So the one is the total, the other one is per unit cost, the other one is the incremental cost. So the marginal cost function is found by computing the change in total cost or change in output. So marginal cost is MC, which is VWQ, which is equal to the incremental change cost by the payment of VWQ, or number of quantity, divided by the partial change in the quantity. So this is what is actually being expressed. Graphical analysis of all these things will give you the following. Like when you have a total cost, means it will be an increasing one with constant returns to scale. Total cost are proportional to the output. So when one unit changes, a proportional cost will increase. So AC is equal to MC in that context. Both AC and MC will be constant in this case. Okay, that is the additional, the average cost and the marginal cost will be, that is the difference. The difference of the MC is going to be zero there. That's it. So graphical analysis of the total cost is also gives you some couple of points, like suppose instead that total cost starts out as a concave and then become convex as output increases, then one possible explanation for this is that there is a third factor of production, that is fixed as capital and labor, usages expand. So total costs begin rising rapidly after diminishing return sets in. So this is what is actually the graphical a picture or the graphic of what we talked about. So it is also having an increasing then an so it has different portion. One is a concave portion, the other one is a convex portion. So you have a point of inflection there also. So then you have the MC and AC curves are going to be looks like this. So MC is the slope of the C curve where AC is greater than MC and MC must be falling. That's it. So AC is less than MC and AC must be high. Now, the cost curve are drawn under the assumption that input prices and the level of technology are held constant. So, any change in this factor will cause the cost curve to shift. Suppose we have a fixed proportion, Q is equal to f of KL, which is equal to minimum AK and BL, or alpha K and beta L. Production will occur at the vertex of the L-shaped isocont. In that context, we have seen this thing in the earlier lectures also. So, but still, as a matter of discussion, this is very important. So you have a C W VQ, which is equal to VK plus WL, which is equal to VQ by A plus WQ by B. So if your cost is, that is your total cost function is alpha V by A and W by B. So this is what is actually going to be given in this illustrative function. Now I have already made, I don't want to talk these things in a detail, and this is simple. We have already seen the CES case and that. So let's go through the properties of cost function now. So homogeneity is a very important aspect as far as the properties of cost functions are concerned. So let's discuss one by one. So what is a homogeneity? Cost functions are all homogeneous or degree 1 in the input price. So cost minimization requires that the ratio of output price be set equal to RTS. A doubling of all input prices will not change the level of input purchase. So this is very important, and a pure uniform inflation will not change a price input decision but will shift the cost curve up. This is the most important element which we have to keep in mind. Then we also have to look into the other thing like the non-decreasing Q, whether it is quantity V and W. Cost functions are derived from a cost minimization process in that context. So any decline in cost from an increase in one of the functions arguments would lead to a contradiction in that context. Okay, so if it is a concave in input price, then costs will be lower when a firm face input price that fluctuate around a given level than when they remain constant that level. So the firm can adapt its input mix to take advantage of such a fluctuation. So what does it mean? So look at the graph. If the firm continue to buy the same input mix as W changes, its cost function would be C0. That is the straight line. Okay. Since the firm's input mix will likely change, actual cost will be less than C0, such as CVWQ1. So that is for that is the curvy, the concave one. So this is what is called the concavity of cost function in that sense. So it is property of cost function again have other aspects. Some of these properties carries over average and marginal cost, then homogeneity, effect W are ambiguous in that context. So a change in price of input will cause the firm to alter its input mix. We wish to seek how K by L changes in response to the change in W by V while holding Q constant. So we know that the partial change in KL divided by partial change in WV. Putting this in proportional terms as S is equal to dou K by L divided by dou W by V times W by V by K by L, which is equal to dou ln K by L divided by dou ln W by V. So this is the log functions will give you a normalized result in that context. So given an alternative definition of the elasticity of substitution, in the two input case, S must be non-negative. Large values of S indicates that the firm changes their input mix significantly if input price changes. So again, another point which we have to keep in mind or have so the elasticity of substitution case we have already seen, that is the input substitution case we have already seen, but the partial elasticity of substitution case between two xi and xj with price wi and wj is given as the following, which is already given, and if the sij is more flexible conception than sigma because it allows the firm to alter the usage of input other than xi and xj in input price changes. Now, how much is going to be the shift in the cost curve? So, size of the shift in cost curve is important. Therefore, the increase in the cost will be largely influenced by relation significance of the input in production process. If firm can easily substitute another input for one that has risen in price, there may be little increase in cost. Okay, so if that is the case, then we'll move towards the technical progress issue. So improvement in technology also lower cost curve, and suppose that total cost with constant return to scale are C0, which is equal to C0 QVW, which is equal to QC0 WV, and why this is, that is technical progress is in that context there is an improvement in technology. So you have to keep the total cost constant return to scale. Okay. So then there is definitely a shift in the cost curve. So this is what has been given. Let me go to if you check with the Cobb-Douglas case also, you'll get the answer. So under the contingent demand for input, same, you have a contingent demand function for all the firm's input can be derived from the cost function, where you get to know the Shepard's lemma. That is, the Shepard's lemma is a simple one. So the contingent demand function for any input is given by the partial derivative of the total cost function with respect to that input price is what is called the Shepard's lemma. Okay, suppose we have a fixed proportion technology. The cost function is CWVQ, which is equal to A V by alpha and plus W by beta. So if that is the case, for the cost function, contingent demand functions are quite simple. So if that AC VWQ is equal to the incremental change which we discussed, that is dou C BWQ by dou V, which is equal to Q by A. Alright, and for the labor contingent demand case, the same, that is change in C, that is partial change in C, that is dou C BWQ by dou W, which is equal to Q by B. So that is what is actually given in the case. So suppose we have a Cobb-Douglas technology, the cost function is also going to be as follows, that is CVWQ, which is equal to VK plus W L, which is equal to Q1 by alpha plus beta, and BV alpha by alpha plus beta, for again W beta by alpha plus beta. So this is what is actually the whole function in the case of copterless one, which we have many times discussed in different contexts. So there is no problem as far as this particular conceptualization is concerned. So contingent demand for input depends on both input prices. Okay. So with this, let me stop that portion, and let us look into the short run, long run distinction of the cost. In the short run, economic actors have only limited flexibility in their action. That is where in the long run everything changes. This is the distinction, simple economic distinction, which normally makes someone in the short run, long run, presentation. So assumes that the capital input is held constant at case 1, and the firm is free to vary only its labor input. The production function becomes Q is equal to F of K1L. In the short run cost for the firm is SC, that is short run cost, is equal to VK1 plus WN. There are two types of short run cost. Short run fixed costs are costs associated with the fixed input, which is what is we discuss as VK1, where short run variable costs are costs associated with variable inputs, WN. That is the wage which is paid to labor. So it is a variable cost. So short run costs are not minimal cost for producing the various output level. The firm does not have the flexibility of input choice. To vary its output in the short run, the firm must use non-optimal input combination. The RTS will not be equal to the ratio of input prices. So if that is the case, then we can graphically present the whole thing. Because the capital is fixed, we know in this particular case K1 capital is fixed, the firm cannot equate RTS with the ratio of input prices. So therefore you have L1, L2, L3, which is changes there with respect to you have a Q1, Q2, Q3. Okay. Now the short run average cost, total cost SAC function is therefore total cost by total output SQ, and short run marginal cost is also given as the change in SC divided by change in output, which is dou SC by dou Q. This is what is actually a relation short run, long run cost curve. So the long run cost curve can be derived by varying the level of K in that sense. So if your K also changes, then everything changes. So that is going to be, you have different short run curves, whereas you have an average cost, an enveloping average cost curve, which is what is called the, as well as an envelope MC curve, instead of two short run cost curves, different cost curves like. So this is what is actually forms the envelope curve analysis of the cost curve. So it's quite easy that the envelope curve or the long run cost curve is a collection, or it is actually the addition of all the short run cost curves, which is actually the firm opted. So it is actually the locus of point of different short run optimal points, short run optimal combinations of that particular firm is what is called the envelope curve of that particular firm in the long run. So that is, in the long run, every factor therefore changes, and that's it. So that is why you have this relation, which is followed from this particular graph. Okay. So at the minimum point of AC curve, the MC curve crosses the AC curve. MC is equal to AC at this point. So SAC curves is tangent to AC curve, and SAC for this level of K is minimized at the same level of output as AC. So SMC intersect SAC also at this point, where you say that AC is equal to MC is equal to SAC is equal to SMC. This is what is called a perfect competition situation. A firm that wishes to minimize economic cost of producing A particular level of output should choose that input combination for which the rate of technological substitution, that the RTS, sorry, technical substitution, is equal to the ratio of the input rental price. So, given all these points, we can immediately conclude the following important points: that repeated application of this minimizing procedure yields the firm's expansion path. The expansion path shows how input usage expands with the level of output. That is, it also shows the relationship between output level and cost. This relationship is summarized by the total cost function C VWQ, and again the firm's average cost, which is AC, is equal to C by Q, and the marginal cost MC is equal to dou C by dou Q, can be derived directly from the total cost function. That is, if the total cost curve has a general cubic shape, the ACMC curves will be U-shaped. So this is how the U-shaped curve got. And all cost curves are drawn on the assumption that the input price is held constant. So when an input price changes, cost curve shifts to new position. So the size of the shift will be determined by overall importance of the input and the substitution abilities of the firm. So if the firm can substitute immediately, then they can actually reduce the shift, the rate at which it shifts. So technical progress will also shift cost curve along with the other things. Okay, so input demand function can be derived from the firm's total cost function through partial differentiation. These input demand will depend on quantity of output the firm chooses to produce, are called the contingent demand function, as we have discussed earlier. So in the short run, the firm may not be able to vary some input, so it can then alter its level of production only by changing the employment of its variable input. It may have to use non-optimal high cost input combination than it would choose if it were possible to vary all input. If that is the case, then this is what we have discussed today. So let me conclude today thanking all of you that very fortunate that you have all listened this lecture. So thank you.